In this video, I'm going to show how to simplify radical expressions and how to perform operations with them. First, we'll look at the parts of a radical. So there are three pieces to this. There's the index, which is a number kind of like an exponent. It's a small number in the tiny corner of the radical symbol. There's the radical symbol itself. It kind of looks like a check mark. And then the radicand is the number inside of the radical symbol. Now, if you don't see a number where the index is, that means it is an index of 2. So when the index is 2, we don't usually write that number in this corner. But there are other types of radicals like cube roots, fourth roots, fifth roots, etc. It's very important that we know all of the perfect squares readily and easily because we're going to be dividing some of the numbers we get by these numbers in purple to help simplify our square roots. Because if we know a number is divisible by 36, then we can divide that out as 36 times some other number and then take the square root of 36 to bring us 6 outside the radical. And the last thing we have on this slide is the definition of the term like radicals. These are specifically radicals that have the exact same index and radicand. So both of these numbers have to match for us to refer to them as like radicals. For example, 3 root 2 and 5 root 2 are like radicals because the coefficient in front is not part of my requirement here. That's a separate number that's in front being multiplied by the radical. These both have an index of 2 and a radicand of 2. So to simplify radicals, we're going to use that list of perfect squares and try to find the biggest number that the radicand is divisible by and split that up as the perfect square times some other number. The perfect square number, you're going to be able to take the square root of that and then bring that number in front of the radical. And I will mention that if you divide it by multiple perfect squares, then you'll just have multiple numbers that get multiplied together out in front of the radical one at a time, but you won't have to worry about that if you use the biggest number possible. So for my first example, I'm going to look at the square root of 54, and I want to start with the number as close to 54 as I possibly can, and then work my way down. So it's not divisible by this, it's not divisible by this, it's not divisible by this, it's not divisible by this. 54 is divisible by 9. So since I have 9 times 6 equals 54, and 9 is one of my perfect square values, now I can split this up and say, well, the square root of 9 is just equal to 3, so now that's going to come outside the radical. And then the non-perfect square number is going to stay inside the radical. And you would repeat this process if needed, but 6 can't be divided by any of my other perfect square values, so in this case, that one is finished. Then I'm going to look at my next example. I have the square root of 72. So I'm starting again by finding the number as close to 72 as possible, so it would be in here between the 64 and 81. It's not divisible by this, it's not divisible by this. It is divisible by 36, so 36 times 2 is going to equal 72. So I found my perfect square that 72 was divisible by, and then I just took the square root of that 36 part to make it 6 times the square root of the other number that's still inside the radical. Now we're going to look at how to add and subtract different radical expressions. Now the first step is going to be simplifying each radical, just like we did on the last slide. So I'm going to need to simplify the square root of 32, square root of 162, and the square root of 98 separately. So the first thing I did was look for a perfect square 32 was divisible by, 162 was divisible by, and one that 98 was divisible by. My next step is going to be to take the square root of those perfect square numbers, and then if you already have a number in front of your radical, the square root and the number out front are going to get multiplied together. So I took the square root of 16, which is 4, but I already had a 2 in front of my radical, so the coefficient of 2 times the 4 from the square root gives me 8 root 2. On the next one, the square root of 81 was 9, and I didn't have a coefficient on this radical. So basically I was doing 9 times 1, that one just stayed as 9. And on the last one, I had the square root of 49 was 7, but I already had a 3 in front, so 3 times my 7 gave me 21. For the actual combining of the like radical step, these all have an index of 2 and a radicand of 2. So all three of these are like radicals, which means I can combine them together. The only thing we're going to be adding or subtracting, though, is the numbers in front of the radicals, the coefficients. Sometimes I find it helpful to explain to students that you can think of the like radicals as an x. So think of this as 8x minus 9x plus 21x. The square root of 2 is still going to be in my answer. We're just going to be adding the coefficients in front. So I've shown you the application of kind of using variables to our advantage in this case. We're using the variable x to represent a difficult number to work with, the square root of 2, and 8x minus 9x plus 21x is 20x. The x stays the same throughout this expression the entire time, in the same way that 8 root 2 minus 9 root 2 plus 21 root 2 will equal 20 root 2. So the common mistake there is sometimes students try to do something to the radicals as well. That's why I think it will help you if you think of them as x's instead and combine them that way. Now we're going to take a look at multiplying radicals. Now my first step is going to be the same as it was on the adding case. We want to try to simplify any of the radicals we can before we do anything else. So here you can see I wasn't able to simplify the 2 square root of 3 part at all, but I did recognize that 18 was equal to 9 times 2. And since 9 is a perfect square, I was able to take the square root of the 9 and bring a 3 out front. But I already had a 5 as a coefficient on this radical, so I multiplied the 5 and the 3 together to get 15. Now the next step is going to be where I actually multiply these radicals together. So I'm going to multiply the coefficients, the 2 and the 15, and the radicands, the 3 and the 2, together separately. So multiplying the coefficients of 2 times 15 gave me 30, and then looking inside of the radicals, 3 times 2 gave me 6. It is possible at this step you might be able to simplify your radical again, but in this case I don't have a perfect square that 6 is divisible by, so my answer on the first example is completed. So now I'm going to do a second example over here. Now my first step of simplifying the individual radicals, I don't see anything that I can break down the radicands of 3 or 5 by. So I'm not going to have to worry about that step on this first one. So I'm going to go straight on to the multiplying step. Now as a reminder, when you have two terms are separated by a plus or minus symbol, so I have 2 terms here, and then I'm multiplying by 2 more terms over here. There's a single minus in between, so I have 2 terms on this. This is where you might have learned the phrase to FOIL them. I just like to call it distributing out. So I'm going to need to multiply very carefully on doing square root of 3 times square root of 3 is the square root of 9. So I'm doing the square root of 3 times the first term. Then I'm going to do square root of 3 times the next radical. So remember, we multiplied the numbers in front of the radicals separately. This one kind of has like an invisible 1 on it. So 1 times negative 5 is going to give me negative 5. But then when I multiply the radicals together, 3 times 5 is going to give me 15. Okay, so I've multiplied square root of 3 times both of the terms in the other binomial here. Now I need to do the same thing with the square root of 5. So I'm going to do square root of 5 times square root of 3. Both of these have coefficients of 1, so there's nothing out front. But inside of the radical, I have 5 times 3, which is 15. And then for the last distribution, I need to do square root of 5 times negative 5 square root of 5. Well, if this one has a 1 in front and this one has a negative 5, that'll give me negative 5 when I multiply. And then I have 5 times 5 for inside of the radicals. So just always remember that you're multiplying the numbers in front and the numbers inside of the radicals separately. Now I still need to simplify my answer from this step, so I'm going to go through and recognize that, well, 9 is a perfect square, so the square root of 9 is just 3. This next piece doesn't simplify. I'm going to leave it alone for now because there's no perfect square that 15 is divisible by. So the same thing is happening on this term. I do not have a perfect square that 15 is divisible by. But on this last one, I know that the square root of 25 is 5. However, I already have a negative 5 outside of the radical here as well. So when I multiply the 5 from the square root and the 5 that I already have in front, I'm going to get negative 25 from this. And then the last thing I want to do for my simplifying, here I'm at the step where I'm adding and subtracting radicals. So if I have any like radicals, I do need to combine those. I also have some whole numbers out front. I have 3 and a negative 25, so I can make that a negative 22 from the whole numbers. And then if I think of this as negative 5x plus 1x, then these will combine to give me negative 4x. So don't forget that we do not need to change the numbers inside of the radicals when we're adding or subtracting them. The numbers inside only change when we're multiplying radicals together, like the 3 times 3 giving me 9 in that case. So that's it for that example. For the last operation we're going to talk about, we have dividing radicals. Now I'm going to focus on case 1 first and do an example, and then I'll come back and talk about this second case and the definition I have here. So radicals are not allowed in the denominator of your fractions. The first thing you'll want to try to do is to reduce or divide the fraction to see if you can simplify it and get rid of the radical. Because if that happens, then you won't even need to worry about these other situations. However, that's not very common. So if simplifying doesn't work, we have to do something called rationalizing the denominator. Now, the first example of rationalizing is when you only have a single radical in the denominator of your fraction. If that's the case, you're going to multiply the numerator and denominator of your fraction by whatever radical you had in the denominator, and then we'll do our simplifying again at the end. So focusing on the example on the left, I'm going to try to just simplify these two radicals before I do anything else. Because I know that the square root of 4, that's a perfect square, it's just 2. But on the bottom, I know that the square root of 24, well, 24 is divisible by 4 times 6. So if I square root the perfect square part, that means this is equal to 2 root 6. So I was able to simplify things, but we did not successfully get rid of the radical in the denominator. I could still cancel out the 2's in the numerator and denominator of my fraction and just make it 1 over root 6, but that still hasn't fixed the issue with getting rid of the square root in the bottom. So now I'm going to go back to what the case 1 on the last slide showed. So all I have left at this point is a single radical in the denominator, so I'm going to multiply the numerator and denominator by that radical. So multiplying this out, on top I have 1 times square root of 6, which is square root of 6. And on the bottom I have square root of 6 times square root of 6, which is the square root of 36, or 6. Now for my second example, I don't see anything that I can simplify on the radicals the way it's written right now. So simplifying doesn't help me from the very beginning of this problem. So I'm going to go on to what the second case that I showed was. So on case 2, since I have two different terms in the denominator of my fraction, with one of them being a radical, I'm going to need to do something slightly similar. I'm going to multiply the numerator and denominator by a number, but the number I'm going to multiply by is called the conjugate. And so that's why I had to give you a definition down here. A conjugate is what happens when you have two numbers, one and or both of them are radicals. You basically just change the sign in between those two numbers. So they don't both have to be radicals for you to have a conjugate. It can be a one whole number and one radical. What's important is that you only change the sign in between those two numbers. So we're going to multiply the numerator and denominator of my fraction by the conjugate of the denominator. So looking at the denominator of my fraction, changing the sign in between is 4 plus root 3. Make sure you do the same number on top and bottom. Don't do the conjugate of the top and the conjugate of the bottom separately. It's only the conjugate of the denominator, but I multiply that on top and bottom. Now the bad news here is I'm going to have to FOIL this out, just like we did on one of the earlier multiplying examples. So if you go through the process of 2 times 4, 2 times root 3, 4 root 3 times 4, and 4 root 3 times root 3. That's probably the hardest one right there. So root 3 times root 3 gave me 3, but I also had a 4 in front of the radical. So it's the 4 times the 3 from the radicals, which gave me 12 here. On the denominator, there's actually kind of a cool shortcut that happens when you multiply a number by its conjugate. You do have to do the first numbers multiplied together, so 4 times 4 gave me 16. But the outside and the inside products should always cancel out. They should always end up being the exact same number, with one of them being a positive and one of them being a negative. So that should happen anytime you multiply a number by its conjugate. And then I have negative square root of 3 times positive square root of 3, which equals negative 3. So my last step here was just to combine the like terms. I had 8 plus 12 equals 20, and then these two were like radicals since they're both index 2 and radicand of 3. So I added the numbers in front. 2 plus 16 gave me 18 root 3. On the bottom, we talked about how these two will always cancel out, so I really just had to evaluate what is 16 minus 3. Since this fraction doesn't reduce anymore, that is the end for that question. So that's it for the notes on operations with radicals. I hope that'll be helpful for the assignment.